Metal fatigue is a serious problem that affects many industries and applications. It occurs when metal parts weaken over time due to repeated stress or strain. This weakening happens because of continuous stress or vibrations that the metal experiences during its use. Imagine bending a paperclip back and forth. Eventually, it will break due to the repeated bending. That's similar to metal fatigue, where the metal becomes weaker and more prone to breaking. This weakening can lead to the formation of small cracks in the metal. These small cracks can grow larger over time with continued stress and use. Finally, the metal part can completely fracture, leading to a sudden and catastrophic failure. This type of failure is known as metal fatigue failure. Metal fatigue is often a silent threat because the cracks are not always visible to the naked eye. It can happen in any metal structure, regardless of its size or application. It is a major concern in many industries, including those that rely heavily on metal components. This includes critical sectors like aviation, automotive, and construction, where safety is paramount. Metal fatigue failures can be both dangerous and costly, leading to significant financial losses. They can cause accidents, injuries, and even death, making it a critical issue to address. Therefore, preventing metal fatigue through regular inspections and advanced technologies is crucial for safety and reliability. Preventing metal fatigue is very important. Metal fatigue can lead to catastrophic failures if not properly managed, making it a critical concern in engineering and manufacturing industries. Engineers have used various methods to combat this problem over the years, constantly innovating to improve safety and durability. One common method is using high-quality materials. These materials are specifically chosen for their superior properties and ability to withstand stress. These materials are more resistant to fatigue, which helps extend the lifespan of metal components and structures. Another method is designing for fatigue resistance. This involves careful planning and engineering to ensure that parts are shaped in a way that minimizes stress concentration points. By optimizing the shape and structure of metal parts, engineers can significantly reduce the likelihood of fatigue-related failures. Regular inspections are also essential. These inspections help in monitoring the condition of metal structures over time. They help identify early signs of fatigue, allowing for timely maintenance and repairs before major issues develop. Non-destructive testing, or NDT techniques, are commonly used for inspections. These methods are invaluable for assessing the integrity of metal without causing any damage. These techniques help detect cracks and other imperfections without causing further damage to the structure, ensuring safety and reliability. Some examples of NDT methods include ultrasonic testing and X-ray inspection. These advanced techniques provide detailed